Hey YouTube, this is just a very quick follow-up to the last video in which we confronted the linear factorization theorem, okay? And the linear factorization theorem, let's just go ahead and clarify this again. It basically says this, if it's very true, let me switch over my pen tool here. If it's very true that x equals some number, we'll call it k, is a 0. We called this a 0 for the first time. We also called it a solution. We also called it I'll transplant this down here, a root. We also call these, of course, x-intercepts, okay? If this is the case, I'll put an if here, then the conclusion we can draw is this. Then x minus k is a factor. Okay, so we say a factor. What is a factor? Again, a factor is something we multiply out to get something else. So in the past, a few problems here, we look at factors that look like, of course, these kinds of things. This is a factored expression. But setting things like this equal to 0 using the zero product property means that we can make statements like, well, then x minus 3 equals 0 and x plus 2 equals 0. Somebody here had to be 0. But basically saying this again, we're saying if these are factors, like x minus 3 is a factor, then what you get when you solve this? And what we get is something that's opposite of that thing. So like here, I'm going to get x equals -2. And so the linear factorization theorem says, hey, you got a solution, you got 2, I have factors. And these factors, what are they? They are opposite of, what? The solutions. So here's the deal. Looking up here, I wanted to kind of use what I know about the linear factorization theorem. It says write the equations for problems having the following zeros or x-intercepts within the following characteristics. So I want this. I want an x-intercept at x equals 2. I want an x-intercept at x equals 5. So what we're going to do is this. Let me try to adjust this here. I think we've got it, maybe. No, there we go. Okay. So if that's the case, then what I can say is that I certainly know this. I know that if x equals +2 is a 0, then x minus my +2 here is a root. And I know that if x equals +5 is my 0 or my solution, then x minus +5 is my root. So this right here already guarantees me that I get these zeros. And you can easily see this because if we set it equal to 0, just arriving at this by the zero product property, which says, hey, you multiply a bunch of stuff together and you get 0 for an answer. Somebody here was 0. But basically, this is the case. These are my factors. I also want this. The parabola opens down and is skinny. Okay, so here's the deal. If it opens down, we can already conclude that our a value here, which what we normally call this, is negative. And then if I want it to be skinny, I want it to be a proper fraction, or the top of the fraction be bigger than the bottom. So like 2 over 1, or 3 over 1, or 4 over 1, we could make this like 4 over 1. This would be a skinnier thing. And then, letter B here, it says use the graph to write the equation. We have some graph here. Some things I notice about this right off the bat, it also opens downward, okay? So if that's the case, then what I can say is this is a negative value out front. I notice that I have x-intercepts at 2, 0, and 4, 0. So these must be x minus +2 and x minus +4. And then in terms of the a value, we say the a value. A value is always, as I go 1 to the right, it is always how far up or down you go to get to this next point right here. And so we say this right here, it went from being at a height of, looks like 1, to being at a height of course, 0 here. So it went down 1. So I could say it went over 1, down 1. And we're going to, it's not a slope, but we say A is this. We say as I went 1 to the right, what did my, up and down do? We went down 1. So we say down 1. So we say -1. That's all I have to say.